Today we're going to take a look at composition of functions. And as you can see from our know here, our know is to write and evaluate composite functions. And our do today, you're going to be able to take a function f of x and a function g of x. And we're going to be able to find the composition of these two functions. Now please take a moment and write down the wicker, know, and do. Our wicker know here today is to learn the word of composition, okay, as you can see here. And our essential question, what is composition? Okay. All right, so let's go ahead and begin our instructional material. Another function operation uses the output from one function as the input from a second function. Now, this operation is called composition of functions. Okay, now how do we write composition of functions? Well, let's take a look at that notation. Okay, here's the type of notation that we are going to use for composition of functions, and here it is. Now, I use this type of notation interchangeably, so make a note in your notes that this type of notation is the same type of notation. They both mean composition of functions. Now let's talk about what this composition of function is all about. Now, first of all, if we take a look at the domain of f of g of x, it is all the values of x in the domain of the g function, such that g of x is in the domain of the f function. In other words, we will take the g function and plug it in for the domain of the f function. Okay, so let's go ahead and see if we can demonstrate what this means. In this example problem, I've written out both types of notation. So you see both of them here. Now what that means is I am going to take this 2 value and I am going to plug it into the g function first. And then after plugging it into the g function, then I'll use that result and then plug that result into the f function. Okay, now looking here, it looks like I have something that's missing a little bit. So let me put it here. There should be a g right there. Okay, so let's take this g of x. Well, actually, it's not x in this situation because this time we know it to be 2. So we're going to find g of 2. And I'm going to take that g of 2 and I'm going to plug it in for the x cubed. Simplifying this, we get 8. So that means g of 2 is 8. Okay, so notice, this 2 is the domain of the g function, becoming the range of the g function. Now I'm going to take this range value, it then becomes the domain value for the f of x, for the f function. Okay, so what we're going to do here is I'm going to take this value and I'm going to plug that value in for the x in the f of x function. So it's going to look like this. And then I'm going to simplify that. So that gives me 24 plus 1, or 25. Now what does that mean? Well, that means that f of g of x is equal to, oops, I better not put x, need to put a 2 right there, is equal to 25. And that's all there is to the composition of these two functions for the value of 2. Now you might be asking, well, is f of g the same as g of f? Well, let's just check it out. If we check it out, we see that, remember the f of x function, so I'm going to put f of 2 is equal to 3 times the quantity, we're going to plug a 2 right there, plus 1. Simplifying that, 6 plus 1, which is 7. It's different already. Now I'm going to take this range value and we're going to plug it in for the domain value of the g function. So that gives me 7 cubed. Okay, now this is going to give us 343, which means g of f of 2 equals 343. Now that's different than what we got for the f of g function. Okay, so g of f does not equal f of g. Now, to go a step further, we can use algebraic expressions as well as numbers as inputs for functions to find a rule for f of g of x. For example, let me just demonstrate what we can do. I can take, and let me change pen colors for this. Okay, what I can do is we're going to take these same functions. So remember, f of x was equal to 3x plus 1. And g of x was equal to x to the third. So what I can do is I am going to find out what is f of g of x. But instead of substituting, for example, the 2 into 1 and take that result, plug it into the other, I can take this here, the g function, and substitute it in for the x in the f function. So that means I will get 3 times, we're going to put parentheses there, I'm going to plug the x cubed in for the domain value of the f function, plus 1, and then we're going to simplify that, so that gives me 3x to the third plus 1. So notice these two functions, if I find the composition of these two functions, not for a value, just the composition of these two functions, I can find that f of g of x will equal 3x to the third plus 1. And that is the new function that is generated from these two functions by finding the composition of functions. Okay, let's try another one here. So again, we are finding f, and this time I'm going to use this notation just to get you used to me interchangeably changing between these two. Okay, so in looking at these, I'm going to take this function right here, and I am going to write it, and I'm going to put a parenthesis there because I know that I am plugging the other function in for it. Okay, so substituting the 2 over the x minus 1 into that, and now all I'm going to do is simplify that. So that's going to give me 10 over top of x minus 1 plus 2. So that tells me that the f of g of x function, the composition of these two functions, will be 10 over x minus 1 plus 2. And that's the composition of those two functions. Next, we're going to see if f of g is the same as g of f. Now, we've already done a situation like this for a value of 2. And did it turn out the same? No, it didn't. Okay, so what we're going to do today is we're going to just verify if it turns out the same here. I bet you can already say, no, it's not. But let's go ahead and just let me show you anyway. Okay, so remember, we have our g function. Remember, g of x was equal to 2 over x minus 1. And remember, our f of x function was equal to 5x plus a 2. Okay, so this time, since I am finding g of f of x, that means I am going to substitute this function right here in for the x value right there. So I will get 2 over, and I'm going to have 5x plus a 1 minus a 1. Now we can simplify that, because that simplifies down to 2 over just a 5x. Okay, so that tells me that g of f of x is equal to 2 over 5x. Now notice that was not the same as f of g of x. Well, folks, that's going to give it a wrap for today. Next class period, I do have a handout that I'm going to be giving you. And, well, I guess it's time to say adios. Have a great day, and see you in class.